Initial equations part 3 of my exercises. And like I said in the previous video, which was a live section, this is going to be the last part for indices. Remember, we've taken, this is the third exercises or set of exercises we are taking under this topic. Remember that again, that this is me using exercises to teach the concepts of topics. All right, and I'm using a book, New National Mathematics. Okay, so and this is exercise 1.7. all right, we took time to select the exercises that captured the three major parts of indices. Number one being the part that dealt with the rules of indices, solving questions that involve the application of those rules. All right, and then second part being the part that introduced initial equations, what we also call exponential equations. And then we are now looking at this other part that now leads to quadratic equations. Okay, so this is also initial equations, but then to solve it, it will take us to quadratic equations. Okay, and then in this channel we have also dealt with quadratic equations, so you can look at them. So let's begin. It says solve the following initial equations, and then the beautiful thing is that you would not be told that this is going to lead you to any quadratic equations, so it is you who is able to decipher that. Okay, so let's go over to this background. Okay, so now let's look at its solution. All right, so the first one says that we are given 2 raised to the power of 2x minus 5 into 2 raised to the power of x plus 4 equal to 0. And then in solving these problems, you also should note that there is also the application of the rules and then other small things that you need to know. And then what is it? First, in this kind of exponential equation, you are going to be doing substitution. And then one of the things that will give you the idea of what to substitute is especially the second or the middle term here. So you can see we have 2 raised to the power of x here. And then if you come to the first term, you discover that you can also simplify this to get 2 raised to the power of x. So once you are able to get the term that you can give a name, then you substitute it with another alphabet, then solve for that alphabet and then return back to get your x, because in solving this equation we are actually asked to find the value of x. All right, so let's go. Okay, so in doing that, I am going to apply the rule that says that if I have a to the power of n or raised to the power of m, that this is the same thing as a to the power of n times m. Okay, so and that means since if I am given n times m, I can split it this way if I care. All right, and that's what I'm going to do here now. I'm going to now write 2 raised to the power of x or raised to the power of 2. Why did I choose 2 raised to the power of x now to be inside? Because I have 2 raised to the power of x here, so I want to separate it here to be alone. And then now obeying this rule here, even if I open this bracket again, 2 will multiply x to still give me 2x. Okay, so we have not changed anything. So bring down what you have, which is 5 into 2 raised to the power of x plus 4 equal to 0. Okay, so what happens next is that we can now say let our 2 raised to the power of x be a variable. We can call it y. So if we do that, then we are going to have that our 2 raised to the power of x, we can now substitute it in that equation. So it's now going to be, here will now be y squared minus 5y then plus 4 all equal to 0. Okay, so very nice. What do we do again? So we can now solve this quadratically. So you see what we are saying, it leads you to quadratic equation. Okay, so to solve that now, we are going to have, I'm going to have y squared minus 5y plus 4 equal to 0. We can use factorization approach. which is to look for 2 factors of 4 that will sum to give us -5, and the 2 numbers will be -4 and -1. Okay, so remember, like I said in that video, I'm going to put the link in the description of this one, and then you can also check up. I'm going to put the tab, up there, and then you are going to see, you can click to check how to solve quadratic equations. All right, so now remember I said there that once you get these 2 factors, open your 2 brackets this way, equate to 0, and then attach y in both or whatever variable you have here, and then bring the 2 factors and attach here. If it is positive, then that will be positive. Both of them are negative, so you put them as -4 and -1, and you are done. So we have y -4 is equal to 0, or y -1 is equal to 0. Therefore, our y is 4 or 1. Right, now we have gotten the value for y, but remember that we are not looking for y, we are actually looking for x. So we will substitute y into this equation. So we will do that means x is going to have 2 values since y has 2. So we'll go for y equal to 4. So what it means is that 2 raised to power x is equal to y here, so it will be equal to 4. And so you have 2 raised to power of x. So in this case now, we will apply the rules of indices, make this to be an index form where the base will be 2. And so that's going to be 2 raised to power 2. And since the bases are equal, therefore our x here is equal to 2. Okay, so we have the value of x, and then we can now get that's when y is 4. So we will now go for when y is 1. And it is already obvious, if y is 1, it means 2 raised to power x is equal to 1. And you know that 1 in base 2 is 2 raised to power 0. And so our x is equal to 0 in this case. So the implication, therefore, is that for that equation we are given, our x is either 0 or what? Or 2. Okay, so, and that is the required solution. So this is what it takes to solve problems like this, initial equations of this nature that lead to quadratic equations. So you first of all find the factor that you need to substitute here, and when you have it, then substitute it. Now immediately you do that substitution, well, you will get a quadratic equation. Solve the quadratic equation to get the value of the variable you brought in, and then afterwards use that variable to get the value of the one you are asked to get, in this case x. All right, beautiful. So let's go to the next exercise, which is number 2. Okay, so exercise 2, we are asked to solve 2 raised to the power of 2x plus 1. All right, so here we are asked to solve this. Okay, again, you can see a pointer to what we are going to substitute, which is another 2 raised to the power of x. Okay, so we will try to bring it out here. So solution. So how do we bring it out from here? We apply the rules of indices that says that if I have a to the power of n plus m, that I can write it as a to the power of n times a to the power of m. So if I do that here, I am going to get 2 raised to the power of 2x multiplied by 2 raised to the power of 1. Is that clear? Yes. Okay, and that's minus 33 into 2 raised to the power of x plus 16 equal to 0. All right, so already you can see exactly what we did earlier on, so which will give us 2 raised to the power of x all squared. Okay, so this will be 2 to the power of x all squared. Remember, it's multiplied by 2, so we can bring it to the front. Then minus 33, 2 raised to the power of x plus 16 equal to 0. So what happens here? We can now make our substitution. Let our 2 raised to the power of x be equal to p. So we can use the variable p there. And if we do that, we are going to have 2 That's this. We are bringing down our 2. Then this becomes p squared minus 33p, then plus 16, all equal to 0. All right. So immediately a quadratic equation has emerged. Okay, so we'll try to solve it maybe by factorization also. Let's see if that works. Okay, so by factorization, we are going to have, okay, so in this case, recall that once there is a coefficient of the variable square that is not 1, you use it to multiply this. So 2 times 16 will give us 32. So we are looking for the factors of 32 that will sum to give us minus 33. And those will be minus 32 and minus 1. Okay, so we would have used the approach above, the one I used up there. That's where I, opened 2 brackets and then inserted. In fact, let's use it so that you will see how to do that if the coefficient of your variable squared is not 1. So, in the case here, the one we did in number 1, the coefficient of y squared is 1. Okay, so what if the coefficient is not 1? How do you solve that? So when the coefficient is not 1, what do you do? Still open your 2 brackets. So equates to 0. Now in this case we have p, so bring in your p, then you have p. Okay, so bring in the factors you got, minus 32 and minus 1. Now because the coefficient of p is not 1, so you use it to divide each of these factors here, so you have all over 2. That's all. Okay, so and that is going to give us bracket p minus 16, then into p minus half. Okay, and that's equal to 0. And immediately you have p is equal to 16 or p is equal to half. Okay, now that's equating the both brackets to 0. So that's the value for p, but we are looking for x. So the same way, you are going to now bring in the first case when p is 16. So you have 2 raised to the power x is equal to 16. So if 2 raised to the power of x is 16, then we try to take it to base 2. That is 2 raised to the power of x equal to 2 raised to the power of 4. And so automatically our x is equal to 4. Okay, so having done that, then let's come over here for the case B. So for p equal to half, so what are we going to have? It means that our 2 raised to the power of x is equal to half. But then we can put half in index form. And if we do that, we will get 2 raised to the power of x is equal to half is the same thing as 2 raised to the power of minus 1. Okay, and so we are done as well. Our x is equal to minus 1 here. Therefore, it means that for that equation, our x is equal to negative 1 or equal to 4. Alright, so either of the two is correct. Alright, so and that is for the exercise 2. Permit me to go to a new page now. Now over to exercise 3. Okay, so exercise 3 is not different from what we have just done in exercise 2. So I'm going to leave this as an exercise for you. Alright, all you need to do is take this 8 to the other side so that everything will be equated to 0. And then you do the same simplification that we did in number 2 to now substitute and then solve quadratically. That's all. Okay, we go over to 4. All right, beautiful. So exercise 4 has something nice. Okay, so what are we expected to do? Very nice example. Okay, all right. So here you can see, right, so it's a little bit different from the other ones we've been doing. And like I said, this is the reason why you solve exercises, because you get to see different ways questions can be framed. So what do we do here? Try to first of all put this one in this form. That's remove the negative power. So this will be 1 all over 2 raised to the power of x equal to 2. All right. So at this point, let's give a name to that 2 raised to the power of x. So let our 2 raised to the power of x be equal to, let's use u now. Okay. So if it becomes u, so what it means is that here I will have u plus 1 over u is equal to 2. Beautiful. So see what you're going to do to get you what you want. Just clear the fraction. So either you multiply through by that denominator here, u, or you take LCM. So either ways you will get the same thing. So if we multiply through by u, so u multiplying this will give us u squared. U multiplying this will cancel out. Look at what I'm saying. U times this, and this times u. Okay, so this will give us u squared. This one will cancel this to give us 1, and that is equal to 2u. Okay, so taking this over, we will have u squared minus 2u plus 1 equal to 0. So this is a standard quadratic equation, and we can solve. Now to solve, the coefficient here is 1, so it's easy. So just look for the divisors of 1 that can give you minus 2 if you sum, and then give you 1 if you multiply, and those will be minus 1 and minus 1 itself. Okay, so if you add these two, you will definitely get minus 2, and the product is 1. So open our bracket, we'll have minus 1 and then u minus 1. So that means the solution is going to be repeated. All right, so and here we will now have u is equal to 1 and 1. That's 1 2 times. Okay, so bringing it back to this, we will have 2 raised to the power of x is equal to 1. Okay, and we can easily put that in base 2, which is 2 raised to the power of 0, and therefore our x alone is equal to 0. Okay, so and that's for number 3. Remember, I didn't mention to us what we are to expect. So for this exercise, we have 11 questions to look at. Okay, so we have 11 questions, and we have done 1 to 4, where number 3 is an exercise. Okay, so let's go to number 5. So for exercise 5, we have, in this case now, our base is 3, so I think it's a little bit different. So let's now look at it, but it follows the same approach. Now, if you watch, you will see that the term we will be looking to substitute here will be x to the power of 3. All right, so we will try to see how we can do that. Okay, so let's begin. By our rule of indices, we can split this to 3 raised to the power of 2x times 3 raised to the power of 1. Okay, so we bring down our 28, and then here, okay, so bringing down this one, remember we can break it down into 3 raised to the power of x all over 3 raised to the power of 1. Why? Because a to the power of n minus m is equal to a power n all over a power m. That's rule of division. Okay, so we can write that here, 3 raised to the power x all over 3 raised to the power 1, which is also 3. And we can also leave this one here as 3. Okay, so we close that bracket, and then plus 1 equal to 0. So at this point, we can quickly substitute so that it will be easier for us. So let our x raised to power 3 raised to power x be equal to y. Okay, so I chose to use y again. So meanwhile here, you have not finished the simplification. Of course, you know that that is going to become 3 raised to power x all squared. Okay, I did that because we've been doing that. All right, so that means here will be, let me write it. So 3 raised to the power of x all squared. Okay, so in substituting now, we are now going to have y squared times this 3, so the 3 will come to the front, minus 28 all over, this is now y over 3, then plus 1 all equal to 0. Okay, so to be able to handle that like we did in an example up, we need to clear that fraction. So, and to clear the fraction, we multiply through by 3. So, and that's going to give us here as 9y squared. Then when 3 multiplies here, it will cancel this one. So we just have 28y, then plus 3 times this will give us 3, all equal to 0. Okay, so at that point, we'll now have to now solve the quadratic equation that has resulted. And to do that, we are going to have, okay, you will use 9 to multiply 3, and that will give us 27. So we are looking for two numbers that will add to give us minus 28, and will multiply to give us 27. All the examples we've been doing, they're almost looking alike, so which is minus 27 and minus 1. Okay, so in that case, we open our bracket, bring in our y, then put in minus 27. Since the coefficient of y is not 1, so you divide by that, which is 9. Then open another one, put y minus 1, which is this. Then divide by that coefficient also, which is 9. And everything is 0. So which means that our y now is equal to 27 over 9, which is actually 3, or 1 over 9. Okay, so you can factor finalize here as 3 or 1 over 9. Okay, so and then to now get our x, you also bring it in here. So for the first case, our 3 raised to the power of x is equal to y, which is 3. And you know that 3 is the same thing as 3 raised to the power of 1. Therefore, our x there is equal to 1. All right, so bringing this up now. Okay, so the second part will help us. We will have that our 3 raised to the power of x in this case is going to be equal to 1 over 9. And then in index form, we know that 1 over 9 is the same thing as 1 over 3 raised to power 2. So putting it in base 3. So, and then using this rule that says that anything raised to, if I have 1 over a raised to power n, that it is actually equal to a raised to the power of minus n. So reciprocal changes to negative power. So this is going to become 3 raised to the power of minus 2. Therefore, our x here is negative 2. And so in finality, our x is equal to 1 or minus 2. And that is the solution for number 5. Okay, now recall that if you have a question, you can always ask, but make sure you mention the minute, that's the time that your question is related to. Assuming you're asking question on this and the time when you're watching is around, let's say 22 minutes, so you mention 22 minutes or 22 point something, you know, to show the exact time so that I can easily get there and then be able to respond to your question. All right, okay, so that is for number 5. All right, so of course expect that I will be leaving some for you as exercises, you know, because of practice, so that you'll be able to practice and then master the act. All right, of course I've given you one, I think number 3. Okay, so let's look at number 6. Maybe I will also leave that as an exercise, but let's see it. So we are giving 2 to the power of, so here we are going to have just the same process. You know, you'll just be seeing addition and multiplication and subtraction. So once you remember the multiplication rule, which is this one, and you remember the division rule, which is subtraction, and then you remember the power rule, which is this one. You know, these three rules will guide you a lot when it comes to this particular type of exponential equations. So the other one is now how to take any number to index form, giving you a particular base that you want. That's the approach we use in getting our final answer, all of this part. Okay, so you see, once you know all of this, it's easy to find your way around these exponential equations leading to quadratic equations. All right, so let's go here. So what are we going to have? 2 raised to the power of 2x divided by 2 raised to the power of 3. Okay, but we can put that in form of division. Divided by 2 raised to the power of 3 minus, this one is 2 raised to the power of x divided by 2 raised to the power of 2 minus 1, all equal to 0. Does it look scary? No, it doesn't. Very simple. Okay, so in the numerator, I will bring in 2 raised to the power of x all squared. So because I'm already seeing that as the factor that will be substituted, now simplify this to give you 8. Then 2 raised to the power of x, this one will give us 4 minus 1 equal to 0. Now you remember that in other cases we've just been having only one denominator, but in this case you have a fraction with 2 denominators. So what do you do? Or 2 fractions with different denominators. So you are going to multiply through by the LCM of the 2 denominators, and the LCM of 8 and 4 is simply 8. Okay, so I am going to multiply through by 8, multiply through by 8, multiply here by 8, and of course here by 8. All right, so now if I do that, of course 8 will cancel 8 here. I will just have 2 raised to the power of x all squared minus here 4 will cancel 8 to give you 2, and that will give you 2 into 2 raised to the power of x. Don't make the mistake of making this 4 raised to the power of x. They are not the same. Then minus 8, and then 0 times 8 is 0. All right, so at this point we can substitute. So let our 2 raised to the power of x be equal to k. All right, so that means k squared minus 2k minus 8 should be equal to 0. And then we have our quadratic equation, which we can then solve. Right, so again, you're looking for, of course, minus 8 times 1 is minus 8. So you're looking for the factors of minus 8, 2 of them, that you will sum to get minus 2. Now, all of this we are using here is on the ground that these equations are factorizable. So, but if you try this and it doesn't work, then you know it is not factorizable. All right, so let's see. What are those numbers? First of all, let's list the factors of 8. Okay, 4 and 2 should be in that border. So it's just to know where the signs will be. So if I put minus 4, if I add 2 to it, that means this one will be positive. I will get minus 2, and if I multiply the both, I will get 8. So that's a beautiful one. Okay, so we will then open our 2 brackets, bring in our k, then attach minus 4, bring in another k, attach 2 plus 2, and that will be equal to 0. So that means that our k is equal to 4, or equal to what? Minus 2. Okay, so now recall that our k here is equal to 2 raised to the power of x. And then there is something that is very important to note. If your k is an index number, then it cannot be negative, because there is no value for x that will make this thing to become negative. Highest, your x will be negative. If your x is negative, then it will give you a positive fraction. For instance, assume that my x is minus 3. I'm going to have 2 raised to the power of minus 3, which is equal to 1 over 2 raised to the power 3, and that's 1 over 8. So there is no value you will give to x that will give you a negative answer as your k. So that means our k cannot be negative. So our k is only equal to 4. And then when we now apply it to 2 That's to this equation now. 2 raised to the power of x is equal to 4. Therefore, you have that your x is equal to 2. At some point, you will not need to be expressing this in index form to know your answer. That's the reason for these many exercises. As you solve and solve, you get used to some of these things. So because you know that 4 is 2 raised to power 2, and so since the bases are the same, your x is 2. So, and that is the solution for number 6. Okay, so we move over to the next one, which is question 7. And I'm also going to leave this as an exercise. What I do is that once I'm sure that the exercise is obviously looking like what we have seen, then I'm confident that you should be able to do it. And then if not, you should be able to raise a comment in the video and let me know if I should do that particular exercise, and that means it's going to be on a separate video. So let's go to number 8. So let's try to look at it. So first of all, you can see that the common term here is going to be 3 raised to the power of x. So I will start evaluating in that line. So I'm going to write 3 raised to the power of x all squared, because it is the same thing as this, minus, here I'm going to have 3 raised to the power of x. Sorry, what you have there is addition, so it's going to be multiplication multiplied by 3 raised to the power of 2. Alright, so here is also addition, 3 raised to the power of x multiplied by 3 raised to the power of 1, then minus 27. Okay, so before bringing everything to this side, because we'll definitely do that, let's first of all substitute. So let our 3 raised to the power of x be equal to, what should I use now? M. Okay, so that means I'm going to have m squared here minus m times 3 raised to the power of 2, which is 9. So that is 9m equal to, here will be m times 3 raised to the power of 1, which is 3. And that's going to give me 3m, then minus 27. Amazing. All right, so you will take everything to the left hand side, and that's going to be my m squared. So here I'm now going to have my 3m coming over will be minus, so I'll have minus 9 minus 3, which will be minus 12. Then minus 27 coming over will become plus 27, and everything is equal to 0. Okay, permit me to split my board now. All right, so at this point I can now do my factorization here. So 27 times, of course this is 1, so we are looking for two numbers that can multiply to give 27 and add to give minus 12. So look at the factors 9 and 3. All right, beautiful. So just look for your signs. Minus minus will do that. Minus 9 minus 3 will give us minus 12, and the product will give us 27. So here is going to now be, open your two brackets, m minus 9 into m minus 3, and everything is equal to 0. Therefore, our m is equal to 9 or 3. Okay, but recall that we are looking for x, so we substitute into this equation. So for the first case, our 3 raised to the power of x is equal to 9, and so our 3 raised to the power of x is 3 to the power of 2. Therefore, our x here is equal to 2. Okay, and then in the second case, our 3 to the power of x is equal to the second value of m, which is 3, and that's power 1. So our x there is equal to 1. So here again we have two values for x, which are x equal to 1 and then x equal to 2. Okay, so and that is the solution for problem 8 or 7. Is it 7? Okay, 8. All right, beautiful. So number 9, maybe you have another exercise. Okay, so here again I'm going to leave this as an exercise. It looks exactly like the first one I gave in number 3. So take this to the other side. Of course, you can choose to substitute your 2 raised to the power x first before bringing it over, so that it will look clearer to you. All right, So put the solution in the comment section also. Let's look at number 10. So we try to simplify. So that's going to give us 2 raised to the power of x times 2 raised to the power of 3. You know, with time, you can just be writing all of this. That's the solution without writing all the power. So this is 8, because you know 2 raised to the power of 3 is 8. And that is minus 15 equal to, so this one is division. So you have 2 raised to the power of 1 divided by 2 raised to the power of x, because you have subtraction there. Okay, so what do you do? Now this is 8. We can actually write this as 8 times 2 raised to the power of x. Okay, it will look better that way. So now, before you start clearing this fraction, let's do a substitution. Okay, so it will look more beautiful for us. So let 2 raised to the power of x be equal to w. Okay, so that means we are going to have 8w, that's substituting here, minus 15 is equal to 2 all over w here. All right, and then here now, what you need to do to clear this is to multiply through by w. So I'll multiply every single term by w, and that's going to give me 8w squared minus 15w, and then if w multiplies this, you get just 2. Now take this to the other side. We'll have 8w squared minus 15w, and then the 2 coming over will become negative 2 equal to 0, and your quadratic equation appears. Then we will solve. Okay, now multiply your 8 and minus 2, that's minus 16. The two numbers that the product will give minus 16 and the sum will be minus 15 will be what? What would that be? Minus 16 and 1. Okay, you have to build expertise in getting these two factors by exercises. Just solve exercises. All right, so minus 16 times 1 is minus 16, and minus 16 plus 1 is minus 15. So you are done. Open your 2 bracket, minus 15, w minus 16, I'll bring in this. Open another one, w plus 1, I'll bring in this, and then that's equal to 0. But recall that the coefficient of w squared here is 8, so I will use it to divide the constants here. So, and you are done. Your w is equal to minus 16. Of course, you take minus 16. Okay, let's take it gradually. So this is going to be w minus 16 over 8 is 2 into w plus 1 over 8. Of course, that one cannot divide, equal to 0. So that means our w is equal to 2 or minus 1 over 8. And like I said earlier on, I think my board is finished, so let me reduce it a little bit so as to finish the solution here. Come back here. Okay, so now, like I said earlier in the previous video, in the previous exercise, I think the one before the last, now the x cannot be negative, your w cannot be negative, because it is equal to a number in power. So that means our w is only equal to 2. Okay, and then if we equate it to this, we'll have that 2 raised to the power of x is equal to 2, which is the same thing as 2 to the power of 1, and so our x is only equal to what? 1. Now, meanwhile, I have ignored that part of you checking that your solution is correct. Remember that that's a beautiful thing to do. That's actually why I love math, that you have a solution, you can actually confirm that that solution is really correct or not, whether you are in an exam or whatever, so that you are sure of whatever grade you're going to get, so assuming that it's an exam. So I can plug in this one into this equation and see if it is going to be true. Of course, it should be if it is a solution. So let's do that. If I put 1 here, I'll have 2 raised to the power of 1 plus 3, which is 4, minus 15. Okay, that's on the left hand side. While on the right hand side, if I plug in 1 here, I'm going to have 1 minus 1, which is going to give me 2 raised to the power of 0. Okay, now look at what we have there. This is going to be 2 raised to the power of 4 is 16, and 16 minus 15 is 1. And on the right hand side, 2 raised to the power of 0 is also 1. And that is very correct. So if you do the same for all other examples we've done, your answer will be true. Okay, my board is full, so let's go to a new one and then have our last exercise for this particular section. Okay, and that is number 11. All right, so this one I think is the only example with power 5 base 5. So of course the base is not the issue. Just know the process. The base, whatever the base is, it will always align. So here you can see that the factor your eye should be on is 5 to the power of x. Okay, so here I'm going to bring it out. 5 to the power of x all squared. Remember that this is solution. Then here I have plus 1. The constant does not have any business with me for now, so I'll bring it down. Then here I'll have 26 into, now break this into 5 raised to the power of x all over 5 to the power of 1, which is also 5. So remove that power. Save your time. Okay, so remember what I would usually say. It is safe to substitute here before continuing this evaluation. So we now let our 5 raised to the power of x to be equal to what variable will I use now? Okay, let me use z. I think I've used many others. Let's use z here. So this is now going to be, if we put z here, we'll have z squared plus 1 is equal to 26 into the bracket of z, which is 5 to the power of x, all over 5. Okay, so at that point, I need to draw this line. It will help me. Okay, so at that point now, I can now start evaluating or simplifying. And to simplify here, I need to clear this 5. And to clear this 5, I will multiply through by 5. And there, oh no. And that is going to give me 5z squared. 5 multiplying 1 will be 5, equal to 5 will multiply here, it will cancel this 5, and I will just have only 26 times z, which is 26z. Now take everything to the other side. We will have 5z squared minus 26z plus 5 equal to 0. So this is a standard quadratic equation which we can now solve. And to solve it, multiply this by this, and that will give us 25. So here again, we are looking for two numbers that you will multiply to get 25. You will add to get minus 26. Again, it is easy to see. And what is that number? Look at it well. Is it possible? Two numbers that the product will be 25 and the sum will be minus 26. Okay, yeah, minus 25 and minus 1. Okay, so the two of them, they do the job beautifully well. Open your two brackets again. Please keep using this approach. It will help you, master it. Meanwhile, we know the normal approach, which is to just replace this by minus 25z and minus 1z, okay? So, and then we factorize, which is still the same thing. All right, so here we are going to have z. We bring in the first one, minus 25, another z, minus 1. But recall that the coefficient here is 5, so we will divide by 5. So when we do that, we are going to have z minus 25 over 5 is 5. And then here we have z minus 1 over 5. Of course, that one can divide. So we have our z to be equal to 5 or 1 over 5. Both of them are positive, so both of them will stand, okay? So we will now solve for our x. Recall that, let me bring down, okay, yeah, recall that our 5 raised to the power x is equal to z. So case 1, it means that 5 raised to the power x will be equal to, we use the first z, which is 5, and 5 is the same thing as 5 raised to the power 1. Therefore, x in that case is equal to 1. Case 2, 5 raised to the power of x again is equal to z. In this case, our z is 1 over 5. The 1 over 5 can be written as 5 raised to the power of minus 1. Finally, our x there is equal to minus 1. So we can conclude here that the x for that question 11 is minus 1 or 1, and that is the solution to this problem. Remember that some books will, instead of saying minus 1 or 1, you know, like we've been given two solutions, they will say minus 1 and 1. Either of those statements is actually okay. All right. So this is where we will end it for this section, and also for the topic indices. All right, so we've been able to cover every single form of question you can find under indices, whether be indices involving the laws, or indices involving exponents, exponential equations, or indices involving exponential equations leading to quadratic equations. And we saw different frames of it in these 11 exercises. Recall that I gave you 3 of them as your own exercise. All right, so that's number 9, number 7, I think number 6, 7, and then number 3. All right, so kindly do those, and then as a proof of understanding, let me see what you have as your solution in the comment section of this video. All right, you can always reach out to us through WhatsApp, through Facebook, whatever means. We have a Telegram channel, which I don't know if it's on my bio. I will try to add it on the bio. All right, and then you can always reach out to us in the comment section of our videos. You can ask questions, request for an explanation to any problem. Please subscribe to our channel. We covet your subscription. Share our videos to your friends, and okay, we'll see you in our next video. The next video is going to be on the topic logarithms. All right, so remember, we are taking it one after the other, and I hope to finish all the exercises regarding the topics you have in senior secondary or grade 7, grade 8, grade 9 maths, and including topics of IGCSE. We are going to be looking at discussions involving those topics on this channel. See you in our next video. Bye.